through chapter 5, number 13, which I think most people have agreed in the past is a fairly complex question, so hopefully I can get this done in just one video. We'll find out. Suppose that the current price of a tablet device is $300 and that people are willing to buy 1 million devices per year. That would be at $300, right? Demand is downward sloping, so if it were cheaper, they'd buy more. That's what the demand curve tells us. Okay, the government decides to begin subsidizing the purchase of new tablet devices. In other words, for some reason, they've decided that these things are something essential, necessary. It's not fair that people don't have them, or they present positive externalities, so that's why the government's going to subsidize them. It's not too hard to imagine right now in the fall of coronavirus, where so many things are online, that there could be something like this, right? It's pretty feasible. The government decides to begin subsidizing the purchase of new tablet devices. And notice he says to subsidize the purchase, not the production of. That means he wants this done on the demand side. The government believes that the appropriate price is $260 per tablet. So the program offers to send people cash for the difference between $260 and whatever the people pay for each tablet they buy. So if no consumers change their tablet buying behavior, which means they're going to continue to buy the 1 million, how much will this program cost the taxpayers? Well, the difference between, this is strange phrasing, but again, he's trying to be like aloof, so he doesn't reveal things about the question. If they're paying $300 and they believe the price should be $260, how much is the government paying for each one? $40, because that's the difference between $300 and $260. So for letter A, if the government, I think I'm going to be able to squeeze this in here, if the government is going to spend $40 each, and there's going to be 1 million purchased, that's $40 million. That's pretty easy arithmetic. Let me show you what I'm doing here on this whiteboard. What I've done is set up the market. Equilibrium quantity is 1 million. The equilibrium price was 300. So if they think the price should be 260 and people are paying 300, the government would say, well, if 1 million are being bought a year at this price that's too high, let's subsidize it so we can get it down to 260. That's 40 each, and that should cost us $40 million. That's the reasoning, and that's what A is about. What's the estimated cost of this program of putting this 1 million tablets out in the world? If they subsidize them for $40 each, the estimate would be 40 million, right? So that's what A is about. That's the first estimate that the government planners might come up with, and that would be Y. Let's see what B has in store for us. Will the subsidy cause people to buy more, fewer, or the same number of tablets? Well, what happens with most things you buy if you can get it for $40 cheaper? Maybe you buy more of them, or maybe you would buy the next one sooner. That's probably what I would do. I wouldn't buy 2 tablets, but I would be inclined to buy my next one before I was really about to throw it through the wall because it's crashing and falling apart and all that kinds of things that I typically do with my laptops when they've reached their deathbed, as I push it too far. So if I could get it for $40 less, I might do it a little bit sooner. And if everybody's behaving that way, then we should be talking about more being purchased. So what we're talking about now is, I have written in my notes, yes, because at 260, the quantity demanded rises to Q prime. And I came up with that because if this is 300, then 260 is somewhere south of it, right? And look what happens at 260. Quantity demanded is right there. That's what the demand curve tells us. At various prices, the quantities that people will be willing and able to purchase, this is a lower price. I didn't put a dollar sign there, I'll do that. It would be out here. And for now, I don't know that number, so I'm just going to call it Q prime. It's something more than Q star was. So we can count on more people wanting to buy laptops or more laptops, tablets being purchased at a lower price. That's the law of demand. Okay, let's see what C has in store for us. Suppose that people end up buying 1.5 million tablets once the program is in place. Okay, so now I have a label there. I'm going to put Q prime equals 1.5 million. I'll write that in. And also causes the market price of tablets to rise to $320. How much will this program cost the taxpayers? Oh wait, I'm sorry, I'm writing into D. C was suppose people end up buying 1.5 million tablets once the program is in place. Sorry, if the market price of tablets does not change, how much will this program cost the taxpayers? Well, that's kind of weird because the market price is going to have to change. So what the author is looking for here is this 1.5 million, right? That's what the author said. It's going to go out to 1.5 million at 260. Well, the government's second forecast in letter C, letter B wasn't really a forecast, it was just something to think about, and I just did that out loud, was that we're now talking about a $40 subsidy because that's what the government thinks it's going to cost to get down to 260. But it's not a million people because at 260, people, the quantity demanded would rise. It's 1.5 million. So 1.5 times 60 is equal to 60 million. So in their second revision here, or the first revision of their forecast of how much the subsidy is going to cost, it's up by 50% over what it originally was. It's not 40 million that they should estimate it to be. It's 60 million. But wait, there's more. Because if they don't do anything, who's going to make that 60 million? They're not going to be made, and they aren't made. So let's see how D reads. Under the assumption that the program causes people to buy 1.5 million tablets and also causes the market price of tablets to rise to 320, because it would have to make that many tablets, the price that sellers receive has to be higher to compensate them for their cost, including their opportunity cost, what they could otherwise be doing. So again, under the assumption that the program causes people to buy 1.5 million tablets and also causes the market price of tablets to rise to 320, how much will the program cost the taxpayers? Here's why I'm saying it has to rise to 320. 1.5 million is here on this number scale. Well, the supply curve, if it's accurate, tells us that to produce 1.5 million, the sellers aren't going to produce more unless they're compensated to produce more because they have costs. They have to bring in people to make an extra 500,000. They have to bring in those raw materials to do that. They have to figure out how to distribute an extra 500,000. These are real costs, and so to compensate them for these real costs, they need a higher price. They also have the cost of their time or what they could otherwise be doing. You're asking all these sellers to make more. They could be doing something else with that time. So to get that to happen, they're compensated for it, just like you or I are for selling our labor. And the price that they need to make that much is right here, and the author is telling us that's 320. So now, to go back to the original phrasing of this question, the government believed laptops, or tablets rather, ought to be 260. So that's how this whole thing got going. But in order for the amount of laptops that would be purchased at 260, which is 1.5 million, to be manufactured, the sellers would need to receive $320 per unit. So now, in order to get the 1.5 million to happen, for letter D, the government is going to have to spend 320 minus 260 times the 1.5 million to get it down to 260. That's what they said their goal was. They're going to have to spend 320 minus 260 times the 1.5 million. And of course, we see that that's 60 times 1.5 million. And these are dollars. And that looks to me like 90 million. So if they were naive in their first estimate and say, well, we want it down to 260 and the market price is 300, we'll just subsidize it at 40. That's what this was, or at $40 per unit. Well, once they do that, people want more units because it's cheaper to the consumers. So now the quantity that they need to be subsidizing is greater than what it used to be because of the cheaper price. So that's how we got to 60. But in order to get that quantity to happen, the sellers need to be compensated to make it occur. They're not going to produce those laptops free of charge, or if we did something different, we would end up with just a shortage because people might want 1.5 million, but they wouldn't be there to make them to be there. The sellers need 320, and so your projection rises to 90 million, which geometrically is just a rectangle. It's notice here you have a height of a rectangle, $60, and here you have the width of a rectangle, the length and width or base and height of a rectangle. And so this area on all of these, as far as subsidies go, this rectangular area right here is how much it costs the government to subsidize the good in the market that we're talking about. And I think we've answered the heck out of that question.